Hi everyone. In this video we'll be discussing the problem largest subsquare that is surrounded by x. So basically this particular problem says that we'll be given a square which will be in form of a matrix, and there are n cross n elements inside this, and either a cell is having element as x or the cell is having element as O. So basically you need to find the size of the largest square subgrid that is completely surrounded by X. More formally, you need to find the largest square within the grid where all the border cells are X. So wherever all the border cells are X, you need to find that largest subsquare inside the given grid. Okay. So if you will see the first example, so here you can see that the n value is 2. So we have been given a 2 cross 2 matrix, and we have been given what? We have been given x, 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 x. And for this particular case, you can clearly see that the output is 2, because the largest submatrix surrounded by X is the whole matrix itself. So basically in this case, the whole matrix will be considered, and the dimension of it is basically 2 cross 2. That is why the answer is coming out to be 2 here. If they would have asked for the area or something, then the answer would have been 4. But since here they are asking for the one side length, so that is why the answer is coming out to be 2. When we'll understand more when we see the second test case as well. So if you will see, when we come to the second test case here, then what happens is, suppose we have been given a test case where we have been given n value as 4, and we have been given x, then x, and then x, and then we have been given 0. Then after this we have been given x, then we have been given 0, then we have been given x, then again O, and then after that we have been we have been given x here, I guess. Okay, so yeah, in this case we have been given x here, so let's write x here. Then after this what happens is, we have been given x, then we have been given x, then we have been given x, okay, and then after this we have been given O. Now after this lastly we have been given x, then O, then x, and then x, okay, x, O, then x, and then x. Now if you will see this particular grid, so it is very easy to determine here that if I will consider the segment which is this particular segment, right? So in this particular segment, you can see that this particular grid that I have highlighted right now, it is basically a square matrix which is having all the borders as x, because the question clearly mentions that more formally you need to find the largest square within the grid where all the border cells are x. So all the border cells being x is this particular red region that I have highlighted, and the length for this particular one side is what? The side length is 3. So that is why you can see that for the second test case the answer comes out to be 3, because the square that is starting from 0, 0 cell, okay, and ending at the cell 2, 2, this particular cell will be the answer. Now how can we solve this particular question? Solving this particular question, if we'll apply the brute force approach for it, then the time complexity would be n cube. Why? Because we will be checking for all the cells, right? We'll try to move from the bottom right of the grid, and then we will try to check for each square from I comma j, right? If we try to do that, then first of all I comma j loop will be there, that's n square, and then again we will check also, so that will take n cube time in the worst case. So if we want to optimize it in better form, so what we can do is we can use the concept of prefix sum here. How that will help us? Prefix sum will allow us to check, like suppose if I am at a particular I comma j cell, then if I have already calculated the prefix sum for horizontal and vertical directions, then I'll be very easily able to check about the other corners as well. So let's try and analyze how we will do it. So suppose that this particular input has been given to us, that is matrix n is equal to 4 has been given, and we have been given this particular grid. Now after this what we can do here is, suppose if we had this particular grid already with us, now what we will do here is we will iterate in this grid in the horizontal as well as vertical direction. So what I will do is, first of all I'll generate a horizontal as well as a vertical grid. So what we will do is we will keep on moving in our grid, and if we keep on finding x, then we'll keep on increasing our count for that particular row. Okay, if assuming that we are iterating first of all in this fashion, so what will happen here is, since we have x, so we'll update this to 1. Okay, then after that, so for every row, suppose if I'm starting, so every row initially the count will be 0, then here the count is marked as 1, then again I have x, so this will become 2, then this will become 3, and then after that I have got 0. Since the moment I get 0, then I'll say that there is a break here, so then I can say that I'll put this value as 0. Then after this, then in the next row I'll start, the count would be initially 0, then it would get updated to 1 here. Then after this what will happen, if you will see, I have a 0, so I'll put this value as 0. Then after this what we will be doing is, then the moment we go to the next value, so here we have marked the count as 0, then after that I go to the next value. The next value that I go to is again x, so we'll mark the count as 1. Then after that the next value that I go to is x again, so I'll mark the count as what, 2, because cumulatively this much segment is of length 2, right? So that is why in between we marked it as 0, because we encountered a O which represents that there is no x. Then after that we see x, so we'll mark this as 1, then 2, then 3, and then 0. Then after this we'll have this as 1, then we'll have this as 0, then we'll have the value here as 1, and then 2. So this is what we have generated in the horizontal format, right? Because if we move in every row, so we are moving in the horizontal direction, so this is the matrix that we have generated. Now similarly we'll now try to iterate in the vertical format, and then we will generate a vertical matrix based on the given x and 0 matrix. Okay, so what will happen here is, now after this when you'll iterate, so we'll mark this as 1, then 2, then 3, and then 4. Then after this what we will do is, we'll mark this value as 1, then here we'll have 0, then here since we again see a x here, right, so then we'll mark this value as 1 because we found an x here, right? Then after this what we will do is, like since we found a like 0 again, so we'll mark this as 0, and then we'll update the respective counter. Then after this, here this will be 1, this will be 2, this will be 3, this will be 4, and here it will be 1, then 0, and then this will be 0 1, this will be 0, and then 1, and then 0, and then 1. So basically what happens here is, it is going to, whenever I'm at a particular vertical or horizontal grid that I have generated by taking the prefix sum, so those indexes are going to tell me that how many consecutive x's are there at a particular cell, so I can very easily check this thing. Right, now once this happens, so once I have calculated my horizontal as well as vertical grid for the prefix sum, then after this what we can simply do is, we can start iterating. So we can start iterating from the bottom rightmost cell, and suppose if I am at this particular cell, so like if this particular cell is having value as 2 and this particular cell is having value as 1, so this basically indicates what, that if the horizontal is having the value as 2, so it tells that in the horizontal direction you have 2 x's consecutively. Then if the vertical is showing value as 1, so it says that in the vertical direction you have only one cell there, right? So you will take the minimum of the two, because you are considering a square. So if you are having 2 consecutive x's on the left side, right, horizontal side, and one consecutive x on the vertical side, then you will take the minimum of the two, because you want to make a square, right? So now once you have taken the minimum, so you will see that whether or not you can make that much square or not. So here when you will try to see, so obviously you will be able to make it, so then you will mark your maximum as 1. Now if you keep on doing this, then what will happen is, at one point of time in this particular question, your ij cell will be at this particular point, right? So when you are here, then you will be at this cell and this cell. So in this particular grid, you will see that this value and this value, the minimum of 3 comma 3 will come out to be 3, right? So that is what is going to happen. Then once you get this particular value, so you will say that, can I get a square? Now the responsibility will be to check that whether or not we can get a square which is going to allow us to have, like, which is going to allow us that whether or not we have 3 consecutive x's or like on the vertical sides as well as the horizontal side. So that is why what we will check is, we will check the cells. So suppose that if this is I comma j cell, so suppose this is what, if I'll highlight this particular cell, so this is suppose I is equal to 2 and j is equal to 2 cell. Okay, now once I'm at this particular cell, so now I need to check what, I need to check several cells. So I will check the cell, that is this particular cell. So I will check I is equal to 2 and j is equal to 0 cell, as well as I will check this particular cell in the horizontal and vertical respectively. So what I will need to check is that whether or not consecutively, if I'm having value as 3 here, so this means that this particular side and this particular side so far is 3, right? That is one thing that is confirmed, that 3 x's are here and 3 x's are here. Now I want to check whether or not on the other sides I have 3 consecutive x's and 3 consecutive x's or not. So that is why what I will do is, I'll check the value at this particular cell. So when I check this particular cell, so I can see that here for this particular cell, this value is greater than equal to 3, and then I will check this particular cell. So here this particular cell that I'm highlighting now with the black color, this particular cell is 3 and this particular cell is 3. So this indicates that here you have consecutive 3 cells and x's on the border, and on this direction also you have consecutive 3 cells. So that is why we'll say that yes, this much length is possible, and then we'll immediately break that yes, this is possible, and then after this we will try to check for the next length. Otherwise, suppose if 3 length was not possible, then we'll check that, okay, if the minimum is 3, then can I make a length of 2 or not? Okay, so then I'll check for the length of 2, whether length of 2 making is possible, whether length of squares with 2 side as 2 is possible or not. If yes, then we'll store it. If 2 is also not possible, then I'll decrease the size to 1. So this is how we are going to do it. We are going to check the edge lengths or the side lengths by using the concept of prefix sum here. So that is why we'll be able to check every time for every I comma j, whatever minimum we have taken out, we'll be able to check it in very fast operation by using the prefix sum. So this is how we'll approach it. Now let's try and do one thing. Let us try and code this problem up. So what we will be doing here is, first of all, I'll just quickly declare this. So first of all, we'll be given this array A, that will be the array for the characters. Now what I will do here is, like once we have got the matrix with us, so what I need to do is I need to first of all start, because I need to store the horizontal as well as vertical array. So what I can do is I can make a 2D DP, and in that DP I can I can make a pair. Basically the first part will be storing for either horizontal or vertical, and second part can store for vertical or horizontal both, right? So basically instead of making two matrices, what I will do is I'll store the values like this. I'll store the value like 1 comma 0, 1 comma 1, okay, and then like if suppose this is the last pair, so I'll store it like 2 comma 1, okay. So like I will have a matrix of pairs so that I can store the horizontal as well as the vertical pairs. So firstly I'm thinking of storing the horizontal pairs in that fashion. So what I will do is I'll simply say that we can declare a pair, okay. We can declare a pair of int comma int, right, and then we'll have a dp array in 101 size. So basically I'm declaring it of the maximum size, but we can declare it of n plus 1 size, n plus 1 size as well. So what I'll do is firstly I'll iterate int I starts from 0, then we will do I is lesser than n, then after this we'll do I plus plus, and then what you are going to do is, so let's say we are done with this, then after this I'm going to mark initially the count for this particular row as 0. Then what we'll do is we'll iterate all the elements of this particular row. So we'll iterate from j is 0, j is less than n, then we'll do j plus plus, and then after this what we will do is we'll check that if the a of ij, if this particular cell is equal to x. So if it is having value as x, then I need to do what? Then I need to increase my value of the counter. So I'll do count plus plus, indicating that consecutively there are some x's, right? Otherwise if that is not so, then I will do what? I need to mark my count as 0, and whatever is the result for this particular cell, then after that I'll update it in ij, dp of ij dot first as the counter, whatever is the counter so far, right? So this way what will happen is my horizontally my matrix would get updated, my dp matrix would get updated. Now I need to update it for the vertical position. So what I now need to do is I need to iterate in this particular grid once again, and while iterating, what I will do here is when I'm iterating, so again I'll iterate and I'll say that I starts from 0, I is lesser than n, then I can do an I plus plus. And if I'm checking the other way around, so what I can do is I can again run a I and j loop from 0 to n, and then what we can do is like just after the I loop again I can declare my counter. So let's say I'll mark my counter as 0, and now checking for the other way around, what I can do is instead of changing the way the loop is written, I can directly check a of ji, because that will allow me to always remain in the ith row and check all the jth columns for it, right? So I will be able to check vertically. Now if it is equal to x as it has been stated, so suppose if it is equal to x, then what I need to do is I need to count the consecutive ones. So I'll do count plus plus, else the moment it becomes 0, then I need to make my consecutive count like count of x's as zeros, right? Now after this is done, then what we need to do is we need to update for the vertical part. So we'll say that dp of ij dot second, that will be updated to whatever is the count for that particular cell, okay. Once I have updated this counter, so now my job is to find the maximum side length, okay. So what I will do is I'll update my maximum initially to 0, because initially we'll assume that the maximum length is 0. Then we need to iterate from the bottom right cell, okay, because we'll try to find the maximum answer, right? So what we will do here is we'll say that we'll iterate from the last cell. So I start from n minus 1, I is greater or equal to 0, then I minus minus, and then j loop will also start similarly. So we can say that int j will start from where? N minus 1 till j is greater than equal to 0. Then we will do what? We will do j minus minus, and once this has been done, so after this I'll check that what is the size. So I'll check this size will be nothing but the minimum of what? Dp of ij dot first, that is the minimum. I will, as I explained in the diagram, that will take the minimum of the vertical prefix as well as the horizontal prefix, right? So dp of ij dot second, so we'll calculate the minimum, and once I have calculated the minimum part, then I will be required to check. So if that size is greater than 0, why I'm running a while loop? Because suppose if I'm checking for length 3, if that is not possible, then I'll check that consecutively can I make a square of length 2 from starting from that I comma j cell as the bottom right cell or not. Okay, so what we can do here is we can simply say that like I can run a loop like this. Okay, and then what I can do here is like I'll have a I dp of ij, and then I will check correspondingly for the side cells. So I will check if dp of I, so I'm fixing my ith row and I'm checking in the column, so I'm checking if j minus size minus 1, if this particular thing is greater than equal to the size, and at the same time dp of I minus size minus 1, right? Plus 1 I need to do because if I'll subtract, so after that I need to add one length, right? So j, if this is equal to the greater equal to the size, as I explained for the sample test case, if this happens, then in that case we can say that yes, we will break from here. Okay, else what we are going to do is, if this much size is not possible, then after this we need to decrease our size, and then we need to check for the other lengths as well. Now once we have done this particular part, then what we are going to do is we are going to update our maximum as max of mx comma the size. And once our maximum is updated, so after this loop is over, we can simply return the mx here. Okay, so let's try and run this and see if it is working or not. Okay, I need to update this as mx, so let's try and run it again. So it is giving some kind of error here. Let's check what is the error. Yeah, so I should check dot first and dot second here. Let's now try to run it and see what happens. Okay, yeah, so one mistake that I have made is that I need to check, for this case I need to check the second, and for this case I will check for the first. That is, firstly I'll check for the vertical and then the horizontal. Okay, yeah, so the mistake is that I need to update my dp of ji, because since I'm checking ji, so I need to update it for the jth row ith column. Okay, now it would work fine. So this was the very big basic mistake that I did. Right, now it is working fine. Let's try and submit this to check if it is getting accepted or not. So you can see that our code was able to pass all the test cases. This particular problem was asked in companies like DShaw. So I hope that you have understood this problem clearly. Thank you for watching this video.